Hello everybody, my name is Martin Azcarate. I work as a robotics engineer in ESA, in the ESTEC establishment in the Netherlands, and I want to talk to you about space robotics. So my role in ESA is to develop different robotics technologies for space applications, and in particular I focus on planetary exploration, like the Martian rovers that you probably heard of. And part of my work is to do research and development in the Planetary Robotics Lab, where I am now, and to develop lab rover prototypes like the one you see here behind me. So looking at the sky from Earth, we find robotics applications in one of the lowest orbiting satellites, the International Space Station, where we have robotic arms that help and support the astronauts in their tasks and activities and allow them to perform some activities that it would be very difficult to conduct otherwise. From there, and going higher in altitude, we find also robotic applications in the servicing of satellites. And there is this very hot topic and interesting topic nowadays that is called the active debris removal, and the use of robotics in order to capture a satellite and deorbit it whenever this satellite becomes non-operational anymore. Going further away from Earth, we find also robotic examples in planetary exploration, like the cases that have reached the Moon or Mars, with landers and rovers that reach these locations. And even farther away, we can also mention the very famous example of the Rosetta mission, where the Philae probe landed in a comet and allowed us to perform some science in situ in the surface of this comet. People tend to ask me whether if robotics exploration will eventually replace human exploration. And actually the answer is very simple, because this is somehow already happening. But I wouldn't say that robotics replaces humans. I would say that robotics is a precursor for humans. Robotics missions nowadays allow us to reach distant and very unknown areas that it would be very difficult and actually very risky to reach by humans directly, because of the environments that we can find there can be very harsh and very difficult to cope with by humans. So robotics are providing us nowadays very, very useful data, very useful information and knowledge about the environments and conditions that we can find in the solar system planets, so that we can even think of sending humans later on whenever the technologies and the astronauts are actually ready for it. A very good example of robotics missions serving as precursors for humans are the Martian rovers, actually. Like the ExoMars mission that will be launched by ESA in 2022. These missions are allowing us to perform a lot of very interesting science in situ in the surface of Mars, and discover many things about the geology, the biology, the meteorology of Mars. And these missions to Mars may eventually allow us even to bring an actual soil sample of the Martian terrain back to Earth. You probably want to know what are the key functionalities that these Mars rovers need to embark in order to accomplish their missions. So actually, each of these rover missions have their own scientific objectives, and this science is the one that is actually driving the design of these rovers. But I would like to first mention the case of the ExoMars rover, and what makes this mission unique and this rover very special is the very complex drill system that it will embark. And this system will allow it to perform sampling operations that go down to 2 meters below the surface of Mars and acquire soil samples that are protected from the cosmic radiation that reaches the Mars atmosphere by these first 2 meters of layer of bedrock. This is something that no rover has tried before, and that's why we are so excited about it in ESA. The second example I would like to mention is the upcoming ESA rover mission to Mars, the Sample Fetch Rover mission, or SFR, which is part of the Mars Sample Return program in collaboration with NASA. The objective of this mission is to collect and bring back to the lander some samples that have been previously taken and strategically dropped by the Perseverance rover, the one that was recently launched by NASA. What this SFR rover will need to embark in order to accomplish this mission is actually a lot of autonomy. Actually, it will need to traverse very fast and autonomously, and also autonomously fetch all these samples that finds along the way. And in order to accomplish this, it will use mainly the stereo camera sensor in order to localize itself as it moves, and also to model the environment and detect the obstacles that it finds on the way in order to find safe paths that allow it to reach the target locations where these samples are. So that was all from the Planetary Robotics Lab today. And if you have any other questions, please feel free to contact me and I will be happy to answer them.